In this video, we will discuss the metro door, its components, switches and adjustments. Let's get started. This is a door leaf and its holding structure. These two rings have teeth on their faces and are fixed on the structure. A pair of rollers is used on each side of the door leaf. They consist of nuts and anti-loosening shim, rings with teeth on their faces, cams with cuts on their threads to lock the cams with the rings, and a bearing. These are fitted in the leaf holding structure. The teeth of the rings are meshed together. This makes sure that the rollers remain where they are adjusted and the chances of slip are minimalized. These teeth also help technicians in adjusting the roller position. In this case, when the cam is rotated clockwise, the roller moves up, which causes the side of the leaf to move down. This is because the distance between the cam shaft and the guide rail is decreased. When the roller is moved down, the side of the leaf is lifted up. The finger guard side of the leaf must be elevated than the other side to maintain V shape between the leaves. The anti-jumping roller is kept at a gap of 0.1 to 0.2 mm from upper surface. Here is the second pair of rollers. A guide rail bears the weight of the door leaf. The anti-jumping roller along with the upper surface prevents the door leaf from falling off the guide rail. This hinge part is fixed with the leaf. The hinge body also contains bushes, a pin, and a lock hold the assembly in place. On the top we have a lead screw. The screw turns are machined in opposite directions such that both leaves move in opposite directions. A mechanism connects the lead screw to the leaf through the hinge. What if the door leaves are no more at equal distance from the center or according to manufacturer's recommendation? This can be adjusted by unlocking the hinge, loosening the nuts and adjusting the threaded tube. Here it is not required, so we reset it to the initial position. A buffer is fastened on the leaf structure. A stopper which is fastened to the guide rail body stops and limits the movement of the door leaf. If the full opening of the door is to be increased by 20 mm, buffer of one leaf should be moved 10 mm inside. The sealing strip thickness should be 47 to 53 mm. A motor at one end operates the lead screw. S4 switch is used to sense door opening and closing. This switch must be operated when the gap between the top of the leaves is between 4 to 6 mm before the door locks. It is very important to make sure that the door is locked, not just closed. S1 switch is used for this purpose. A cam is attached with the mechanism to operate this switch. This cam operates only when the door is locked. When the door is opened, the cam returns to its initial position. Switch S2 is manually operated only when some fault occurs in the door and it cannot continue its normal operation. So the door is isolated. On the inside, a secure lock is provided to operate it. The door is provided with an emergency escape device. When it is turned by hand, the door unlocks and it can be opened by force. S3 switch operates on operating the EED. The metallic part on the bottom of the door body has an anti-friction strip. This strip slides within the threshold. The gap between this edge and the threshold should be 11 plus minus 1 millimeters. It is important to note that this gap is likely to be affected while adjusting the V shape using the guide rollers. The gap between the inner and the outer threshold should be 16 to 19 millimeters.